This is one of the Fpso operating in the North Sea, Glen. The ship was built in South Korea and is anchored to the seabed at the Schiehallion and Lyon oil field in the North Sea. It is said by British Petroleum to be the largest harsh-water Fpso ship in the world. Glen have a length overall and breadth extreme 270 by 52 meters. It was built on 2015 and have a storage capacity of estimate of 1 million barrel of oil, production rate of 130,000 barrel of oil and 2.2 million m2 gas per day. Glenloy FPSO is operating on the field located 175 km west of Shetland Island in Block 204 and 205 of the UK continental export route for the charter tanker to the refinery or shore oil tank storage. The field is also known as the Schiehallion Field was discovered in 1993. Recoverable oil reserves of Schiehallion are estimated to be between 450 to 600 million barrels. Environmental condition in North Sea and the current weather in the North Sea is as shown in the diagram to be a bit of windy and rain, but through the research, Scotland spell of fine weather in May and June. The climate of the North Sea is strongly influenced by the inflow of water from the Atlantic Ocean and strong westerly wind. The North Sea is characterized by large variation in wind speed and direction, high level of cloud cover and high precipitation. Here's a max temperature of 17 degree and the lowest minimum temperature of 60 degree in the North Sea.
This video W presentation, which is about North Sea of FPSO ships. So the number of new builds and conversions are this much. The highest one is in the new builds. The new builds are the highest in the North Sea. So we come to oil production. Oil production, BP are on the max now. There has the max oil production, which is 320 in the North Sea. Okay, so for storage capacity, Shell has the highest capacity in the North Sea of FPSOs. Okay, go to mooring system. Mooring system of FPSO. So the most used mooring types is internal turret and external turret, which are the most used mooring types and mooring systems, we would say, in the North Sea as FPSOs. Okay, this is the length and breadth of the each FPSOs in the North Seas, and this would be the length and depth of the FPSOs which is existing in North Sea, and this is breadth and depth ratio of the same FPSO ships. So the last one is the draft and depth of the FPSO ships which are existing in the North Sea. So that's all for in this video. Okay, thank you.
Hi, today I want to present this criteria for the wireless of floating propulsion system and why we choosing this monohull and why we need to carry out the model test. The monohull and semi-submersible come in this water depth up to this 3,000 meter, and the spar extension leg platform is 1,200 meter depth and 1,500 meter depth. Come to this layout and processing capacity. The monohull is larger compared with this semi-submersible spar and tension lift platform. The physical shape of future production facility in the North Sea appear to be a larger extent monohull. The floating production system are intensively used nowadays for both shallow and depth water developments and are being actively considered in ultra-depth water allocations greater than 1,500 meters. So the monohulls are the most popular concept, and larger production capacity operate in the depth to outer depth and larger of a processing capacity. The Green Lion is one of the new build house Fpso. So most of the Fpso and Fpso are shaped and can be secured to the sea via the variety of mooring system. So the new build house Fpso is the choice of which is determined by the specific environments. They are suitable for a wide range of water depth, environmental condition, and can be designed with the capability of staying on locations for continuous operating for 20 years or longer. Model test is one of the effective way to verify the numerical dynamic analysis of Fpso system. So the Fpso with the internal turret mooring system under irregular wave, wind, and current are also studied in the deep water basin of Harbin Engineering University. The results are compared between the model test and numerical models, which show the model test results agree well with the copper numerical model, while the maximum mooring tension are underestimated in quasi static analysis. Thank you.
Hi, Mr. David. This is a general arrangement for Glen Lyon Fpso. It is built to produce 130,000 million barrel per day, and also is built to defy harsh environment. And one thing special about this Fpso is using bogie internal turret. As for proposed topside production, it has storage and risers and wellheads that are connected in the center point of the turret so that the ship can weather vane to withstand wind, waves, and current. And they also have all the normal things that Fpso have, such as oil processing train, compromising of sludge catcher. They have drying facilities, produce water treatment, and flare gas recovery, and etc. For the offloading, the crude oil is transferred through pipeline onto the shuttle tanker storage and pipelines heading to Rotterdam, and as well as for gas is transported to Saltum Vo terminal via pipeline. For proposed subsea system, this field has total of 54 subsea wells, and they just added about 20 wells for in quad 204 and 205. For proposed mooring, they are using bogie turret in the forward tank of the vessel. They have swivel deck, manifolds, and mooring lines, and also they also use S-type flexible riser. And for proposed riser, they are using umbilical that uses electric and hydraulic to control you and uses for emergency shut off for the smallest diameter riser. And they also have 24 riser with pliant wave or loose S shape and umbilical and the mooring system. This arrangement is to prepare for the harsh environment, and they uses Technic services to deliver the largest riser system. That's all I have. Have a good day, Mr. David. Thank you.